Okay, can you see my screen?
Yeah, sure.
Okay, so last time we have discussed about some NumPy functions to create NumPy arrays, and these are few of them, and we have some description about them. These were like pretty much simple. This is to just create a new array. We can pass a simple Python list, tuple, or set, or anything, any sequential data type in this function. And same goes for these as array. We can pass another array, or we can pass the same things, like sequential data types. A range, it creates a range. We specify a range that generate a numpy array starting from this to this or something like that. Create a numpy array filled with ones or with zero or an empty, or a full numpy array with a custom value. Maybe fill all the given values in numpy array with 5 or something like that. I is that kind of like identity, I don't know, yeah, identity matrix, like the diagonal part of the matrix, like a square matrix is 1 or 0. It's something like that. So yeah, today we needed to discuss about numpy data types. And yep, usually if you don't specify numpy data types, as you can see they are specified here, this is nothing but just a numpy function which we already saw, like up there, np.array, and we are just passing a list. It would be okay if we haven't like passed this or like given this thing. It would have worked totally. Let's actually try that. Let's import numpy as np. NumPy data types, and here we go. If I would just simply run this array1, it works, it really works. And if I try to check the d type, array1.d type, yeah, it would like simply show me what's the data type of this array. Data type is integer 32, but let's suppose I wanted to make it probably int 16. Yeah, sure, I can do that. Like, let me just copy this right here and do this, Control Z, to differentiate between two examples. Like, see, here we have 1 2 3, here also we have 1 2 3 per, but our data type is really changed. This time it's integer 16. I had a chart, but I guess it's difficult to find that. That's nothing but that chart help us identify the ranges, the number which could be stored in these different data types. Obviously integer 8 can hold probably something like this, if I am not wrong, 2 raised to power something. How to give raised to power, scientific. 2 raised to power probably 8. It's something like this. I can only store the maximum number I could store in integer 8 data type is 256. Let's actually try that. Let's suppose I have let's actually copy that, and I would try to give you an example. 256, and the data type is integer 8. Let me try to run this. Let's see if it works or not. Let's suppose it's saying something like this. It's 0, but it's not really 0. It's 256. Let me do 255 in order to see if it works or not. It's saying -5. Okay, I don't know what's happening, but that's
Because it's counting from 0, right?
uh I don't know. Let's do 1 and 2. Let me try to see 1 and 2. Yeah, that's working. 256. If I do 256, it's 0. Oh yeah, it's from negative to yeah, you're right. Let me divide that with 2. If I divide 1 to 8, probably the max it could store is 1 to 8. It's saying -1 to 8, but I don't know. Like, I guess I need to see the chart. 155, that works really. I guess 120, if I do 120, yeah, it's working. 122, It's also working. 125. Yeah, sure. 6. Yep, I guess 7 because 0 is in that range, I guess, right?
Yeah,
I
that's
can
right.
store up till minus 127. I can't store 128 because it's, oh, I can really store that. I don't know how does it works. Yeah, up till 128 minus 128, and I guess in positive it's 127 if I'm not wrong. Oh, it's even 128. So it's like, see, in integer 8 I can only store number like this, but obviously in integer 16 the range gets doubled or something like that, and same goes for this point is really helpful when you're having a data set and it's maybe 3 GB or 4 GB, and in that data set the data type of the NumPy array is probably something like this, probably maybe integer 64 or something like that. You can actually downscale that up to integer 16 because like that data set only contains is like a image data. In those NumPy array we are only having the image data, and in images the minimum value is 0 and the maximum value is 255, I guess, if I'm not wrong.
Yeah,
So
255.
even if you could use like integer 16 or unsigned integer 16, what does this mean? Unsigned just starts from 0 up till probably something like that, 256, or I don't know what's like if I take 2 raised to power 16. Oh, I can store this much number, so you could think of that. Or maybe unsigned integer, I can even store that in unsigned integer. Like if I try this right here, unsigned u int 16, u int 8. Yeah, if I try to do 129, can I store that? I guess I can store that up to 255. Yeah, see, you could use just simply unsigned integer 8 because here the range starts from 0, so we can't really store -1. It's just picking up that dummy previous cache memory or like junk memory, but I can really store 0. Like, see, I can. So this part is like, it's not really important, but sometimes it is important because you're having huge amount of data and you want to reduce the size, so you could just play with the data type of that array and reduce the size of that stuff. Basically, whenever the NumPy array is storing this array onto your hard disk, it will require this much space, integer 8 space. Like, no matter if you're storing 0 in that or you're storing 128 in that, it requires the same space. So increasing the data type increases that box size. No matter what you're storing inside that box, it will require that that much volume in the memory. So I guess, yeah, that's it. In float we are having decimal kind of thing. In complex number it's like a iota thing, 16 plus kj or something like this, 16 plus 8, something like this, complex numbers. And boolean, obviously you know about that, true false. Object is in NumPy array usually strings are referred or converted as object data type, and Unicode or something else, like I don't know, those are characters, but special kind of characters. Probably you have seen on some website we are having these colons, but they are like a rounded kind of double quotations. Those are kind of special characters, if I'm not wrong.
See.
And I guess, yeah, that's it. The example they have given here is like they have stored this list with numpy.float. If they will store in this float, obviously you will see like 1 point something after this because they're using this float data type. If I check this right here and if I press this ARR1, you will see like, let me zoom in, 1 point, and after that we have 0, but they are not displaying that, but technically it's something like this, 1.0 and 2.0 and something like this. Why? Because we are using this float data type. And in next step, yep, integer. This time we will have a pure integer kind of thing, ARR2, and yeah, as you can see right here. And then data type would be this is like we are specifying the data type by ourselves. And yep, that's a way to check the data type. And yeah, Data type are a source of NumPy flexibility for interacting with data coming from other systems. In most cases, they provide a mapping directly onto underlying disk or memory. Like that's nothing, they're just like NumPy is a kind of smart tool. If you will not specify the data type, it's pretty much smart. It will detect and choose the best data type. If I just simply remove this and try to check the D type of this thing, D type, you will see it has used integer 32. But if somewhere down there I put like 2.2, so this time NumPy would simply convert all of them into float, because NumPy can't convert integer into float. Oh yeah, it can convert integer into float, but it can't really convert float into integer. So it will just, you know, apply the float converter type to remaining values. Here you can see 1 point, 2.2 and 3 point something. So yeah, NumPy is pretty much kind of smart, not really, but yeah, in terms of data types, yeah, it guesses the appropriate data type. Don't worry about memorizing the NumPy data type, especially if you're a new user. It's often only necessary to care about the journal kind of data type you're dealing with, whether float point, complex integer, boolean, blah blah blah. When you need more control over how data are stored in memory and on disk, especially large data set, it is good to know that yeah, they are talking about the same thing. If you're having like a big data set, and you can play with NumPy to reduce the disk size of that data set, but still keep the original values, or you know, whatever is stored in that stuff. And what's here? Yeah, if the array is already, you know, created and later on you want to change the data type, let's add a comment. Later on, change the D type, and here we go. Here is our array ARR, and we can do ARR dot as type. This is the method, if I'm not wrong. Yeah, the method, or you could say the function, to change the array type. And we can specify, either we could use these double quotation and say integer 16, or we could use array dot as type, and we can use np dot int and something like that, int egr, and they would, you know, give you a list of all of them, so you could just simply pick any of them. And let me just try to run this. See, in this, the first part, they have converted that into, yeah, these are same, because here I'm just, the syntax is different. Here I'm just giving the data type in string, and here I'm like, from NumPy pick up this data type. And yeah, that's how we convert them. Well, maybe I can do float 16 in order to see the difference. Float, and yeah, here you can see, here it was only integer, and here it's like a decimal kind of thing. And I guess, yeah, and the thing to remember is, when using this function like as type, it will not create it will create a new array. It will not modify the previous one. So see, they're storing the result in this variable, and then they are checking the data type, and yeah, that this data type and this is same. So yeah, in this place, if I would again run this thing ARR, the data type of this thing would be still the type. It's still integer 32, because we didn't save these converted arrays into something. But if I will write ARR is equals to something like this, then for sure we will get the new data type. What's wrong now? Probably something like this. Yeah, 16. It got converted from integer to float. Yep, float 16. In this example, integer word casted to float point. Let me see, these are float data sets, and this is our float type array, and we are, you know, converting that into integer 32. like as you can see in integers we don't have decimal points, so all of these are kind of skipped. NumPy hasn't rounded them off, if I'm not wrong. Yeah, it's 2 and here it's like something like this, 2.6, but it has, you know, just deleted the decimal part. It's not rounding off. So yeah, be careful when you're changing the data type, because you could lose some data if you're converting from float to integer. I guess it was easy part, nothing kind of really crazy here, right? As a string data type in NumPy is fixed size and many crunches, blah blah. Anyways, as data type, yeah, this is something else. Like you're having two different arrays. This one is range, numpy.a range, like numpy array having number from 0 up till 9, and this is the second array. In this array we have specifically defined the data type, which is numpy float 64, and in this third line 48 actually, what we are saying, like in int array, like this first array as type, we are interested to change the data type, and what we are saying, go to this calibers, yeah, go to this calibers array and pick up the data type of that array, and then use data type of this array and change the data type of this array. Like, did you got this line, or we're just like change the data type of this array to the data type of this, like whatever is the data type of this array, just change the data type to that for this one. Like, is it clear, or do we really need to do that?
Yeah, I understand it.
Okay, then it's great. Nothing special, but that's just a fancy way to use the data type of another array. It's pretty much something like this. We're just passing float as something like this, numpy 36, but here we are like, go get that data type of this and then use that in this statement. Okay, what's next? There are shorthand type of strings. What's this? Data type u4. Let me see the shortcuts. So yeah, that's what they're referring to. For integer 8 you could write I1, or for float 16 you could write F2. These are the shortcuts which NumPy really understands. That's what they're saying right here. If you see where they are, like u4, unsigned integer 4, probably like that. Yeah, unsigned integer 4 means an unsigned integer 32. So yeah, we also have some shortcuts. They do the same job, but I don't know, we could simply write NumPy unsigned integer 64, or just unsigned integer 64 in string. Calling as type always creates a new array, even if the new data type is same as the old type. So yep, it always creates a new array, this function as type. Arithmetic with NumPy. Let me show you what we will really cover. Like, do you have this book, or do I need to share this book with you?
No, I was just thinking of it. You can share it, please.
So let me make you go through this. So the first part of this chapter, NumPy, we are creating the NT arrays. Yeah, we have discussed that. Data types, yeah, we have discussed. Arithmetic, this is really easy. Arithmetic is just like how to multiply and do arithmetic operation, mathematical operation. Basic indexing, slicing, boolean, and yeah. And after that, what we have, universal function. Yeah, we haven't done that, but we will do that. I'm just, making you see all of that stuff and expressing conditional stuff and that stuff. Probably we need 2 more sessions, because we have 4.3 and this part, not random part. Hardly 2 sessions, but I don't know. Yeah, 2 sessions in this NumPy array, because already today we just have 1 hour left. So yep, let's go through this. This is really easy. Arithmetics with NumPy, it's nothing. We are having 2 arrays. Actually, let's create them and let's do that. Then we'll go through the book. MATIC operation in the array, and if I paste something like this and ARR, and yeah, this is our array, and what we can do is array multiply by array. So yeah, that's called multiplication. Multiply, yeah, we are just multiplying. And the multiplication, oh, I'm messing up with this one. Multiplication, oh, I don't know, whatever. This one is multiplied with this one, and this two is multiplied with this thing. So this is probably element wise multiplication. Each element in this list is multiplied with this list. Obviously, every time we don't need element of kind of thing, so we can just simply pass maybe 5. So all of the array would be multiplied, all of the values in that array would be multiplied with this number. So if you could see 5 1 2 3, so 5 1s are 2s are 3s are, and 5 multiplied by 1, that's it. You could do array wise, what that is called, element wise multiplication, if you have the same array or something like that. Let's pick up the first chunk, maybe the 0 one, and let's try to multiply it with that. First chunk is 1 2 3 and 1 2 3 and 1 2. So yeah, this thing got multiplied with itself, and then later on with this. So yeah, that's it. 4 multiplied by 1 is 4, 5 multiplied by 2 is 10, and 6 with 3. So yeah, nothing special, just multiplication. And same goes for the other thing, array minus 2. So yeah, that's what we are getting, array plus, or you could just say divide 6, and yeah, it just multiplies all of them
Divided.
each. Divide. And if you have noticed, this time we are not using any kind of loop, and that's what they were referring to. We don't need any loop in these NumPy arrays. But if you remember, if there was a Python list and we needed to multiply each value inside the list, we can't really do this, say multiply by 3. It did, but what it did, it repeated this whole kind of thing. It didn't multiply, and for that we needed to use a for loop for I in A, and then we could just simply do is like I multiply by something like this, and we could get the same result. We need to print that actually. Print, but the thing is, yeah, we printed the result, but we again need to modify the list or make a new list or change the values of this, so we need to do even more work. But in case of these NumPy arrays, if you could see, we are just using the arithmetic operator and the value with which we want to do that stuff. So that's where NumPy is kind of useful, and yep, that's what they are referring to. And even though we can take the square or under root if it's 0.5, let's take that. Let's take the cube of this array, and the cube for this array is simply something like this: cube of 1, of 2, of 3, and 4, and 5 and 6. And yep, I guess that's done. This part is pretty much done. And here they have just showed a little part of logical, like how to build logic in this array. And let me create this array in order to ARR1 and ARR2 to make you see something like this. So ARR1, why it is 1 2 3. ARR1 should be something like that. ARR2. Let me print that here. Oh, why is it like that? Oh, it's just ARR, okay. So yep, here we go. And here it's the problem, or the example is not really good, but it's just an example. They are just saying, NumPy, go and find me this thing. find me like go and check this condition in both of the array and return me true or false. Why true or false? If that particular condition is true, then return me true on that particular index, otherwise return me like false kind of thing. I could simply do array greater than array 2, just go and compare array 1 and 2 and return me true where array ARR is greater than A22. And if I'll run this, you could see in this part I was on the first index I was having 1, and in the second array I was having 0. So the condition was true, so it returned me a kind of true thing. And for the next thing it's false, and here I again have a true, false, true, false. That's nothing, that's just a condition. I'm telling to NumPy just compare both of these array based upon this particular condition and return me a boolean kind of map or this kind of thing. The shape of this thing would be same as both of them, because this answer is referring to a particular index. It's like on this particular index, and what's the index of this thing? If I could store this in B and I could print this on the B, and I can really go through the index. I'm like, go to the 0 index and again go to this thing. So on this thing I'm having 0. So the answer is even placed in a specific way where I could access a particular value. Maybe I want to check this 5. What's the answer for this index? The index here is like 1 and 1. Yeah, I'm like, go in array, pick up 1 and again 1, and I want to see what's the answer of this thing. I can do the same thing. I just need to enter B and I'll get the answer. So the answer we are getting, it's pretty much kind of organized. It has the same indexing as our main comparison NumPy arrays. Like, I hope you got this. Like, what's your thought on this thing? Probably you have done something like this before, right?
Yeah, it was similar, but I mean, this I'm understanding that I'm understanding NumPy, the value of it over just working on using just Python, because it helps to be able to make some things simpler to do and to not overly elaborate on pulling functions, and it makes things faster. Bottom line, that's the way it looks.
Yeah, exactly. Even though if we wanted to compare two lists in Python, we would have to write maybe 5 to 10 lines of code, but here we're just passing the comparison operator, which is like just a greater than or something.
You can do the same thing with fewer lines of code.
Yeah, a few lines of code with Python list. Let's suppose I needed to loop for I comma v1 comma v2, and I needed to zip both of array ARR2, and then I was like print what v1 is greater than v2, just print this. I'm getting the same thing, but this time it's just few line, but here I'm just printing. I'm not getting a kind of proper array. If I want to get a proper array, then I need to first convert this thing into a list and then pass these both lists into a NumPy thing, something like this. I need to pass the first thing here and the second here. So yeah, couple of lines if I want to do the same thing with Python list. So yep, you're right. Yeah, here we go. This was not they were just making you familiar with that stuff. They will like later on discuss about this thing in depth. But yeah, we can do something like this. We could compare, or let's make it a bit more simpler. This is our first array, and I'm like, if array is greater than maybe 4, just tell me where array is, where this array is greater than 4. It will simply tell me at this position, no, 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 but at these two position, yeah,
And just
the
the
array
one.
is greater
Yeah,
than, yeah,
five
yeah,
and
yeah.
six.
Sorry, what did you say?
I said 5 and 6. And if you put an equal before the 4, then it will
Yeah,
increase
it
4.
would. Yeah,
No, after it.
greater than equal to. Yeah.
Yeah, yeah.
Yeah, you're right. Yeah, you got it. So, yep, that's what they were referring to right here. Basic indexing in NumPy. I guess you're pretty much familiar with this thing. That's a simple array, and if you want to access the fifth value, we need to pass the 5 here. 0, 1, 2, 3, 4, 5, and we will get this thing. And if you want to get a range of that stuff, you're like start from 5 and end on 8, but technically it will end on 7. So that's what we're getting, 5, 6, 7 right here with this kind of indexing. Like, let me know, like, I hope you're familiar with this stuff, right?
Yes, I am. Definitely.
Okay, that's great. And what's happening here? They are like, okay, go to 5 and go up till 8, not exactly 8, and change the value to 12, and you will see the value got changed. So yeah, you can play with this indexing stuff. And what exactly do they have next? Yeah, make a slice and store that in the
Slicing.
in
Yeah.
yeah, in a variable. And then this is our new kind of variable, which is
Yeah.
again an array.
And 5 to 8.
And
Yeah.
and what they are doing, they are like, okay, go on array slice, go on position 1, index 1, and change that to something like this. Let's do this. This is a good example actually. Okay, what are they doing here? Let's just copy this. What was the heading? Basic indexing and slicing. Okay, and if I pass this right here, ARR, that's our array. And what's the slice size they have? They change that to this. Let's also do this. Let's actually do that here. So we could just see a one line code, and that's the slice they're making. Okay, and let's also print the slice. And here we go, this is the slice, and this is the original array. And what's next? Okay, now what they're doing is they are like, okay, go in the sliced array, which is this one, and change the index 1 value to something like this. If I'll run this, you will see that's for sure that the values in this would have changed. It's like 12 and 1 2 3 4 5 and 12. But if I print this, the original one, what do you say? Will the values in the original one also change, or will these stay untouched like this? What's your guess?
I'm taking a look at it.
Sure.
Um,
That's how we have break down that stuff. This was the original
Slice.
one. This is the slice, and then inside the slice, I'm like, change this value to this thing. And for sure, we got like 12, this, and 12. And my question is like, yeah, in this sliced array, yeah, this thing got changed. But will this changing, updating the value, will affect the original array, or the original array will stay the same? What's your thought on that?
I think it will stay the same. I guess. Just my guess. Not that I'm sure.
Okay, let's actually check that. And boom, it's not kind of same. And the
But it changed
reason,
the original one.
yeah, the reason is like, yeah, we made a slice, but this slice was not actually a copy. It was just a reflection of, original array. But
The
if
original
right
one.
here I'll do dot copy, oh sorry, see you.
And it's recognizing it as a separate
Yeah, and this
array.
time it will store a copy of whatever I have sliced. But previously, it was not doing that. It was just, picking up it was in this variable I was just having the reflection of the original, array. And let's now try that. If I run this and this and this and this, see, this time 12, 12, 12, nothing is changing. But as soon as I will remove this copy, then it's no more copy. It's just the reflection. This part was a chunk from this array, and obviously if I will change something in this chunk, it will reflect the original one. Or if I will change something in the original, and that is, if that is part of this chunk,
So
for sure that will also change. So these two are just reflection of each other's.
it's still essentially part of it.
Yeah, exactly. Nothing has kind of really separated, but that's a view that, I don't know. We're just getting a view of the original one, view of a particular part of the original one, and that's it. And this time, like, see, they're like in slice, from start to end, change the value to 64. But in slice, we were already having, for three values actually, so only those three got changed to 64. So yep, that's what they're referring. If you want to create a slice and you want to work on that, and your approach was to, I'm creating a new variable so the original would stay the same, then that's not the case. You need to really create a copy. This is just, a view of the original kind of stuff. And yeah, that's what they are saying here. If you want a copy of a slice of an ND instead of a view, you will need to explicitly copy the array. For example, something like this. And yeah, that's what they are referring to. And yeah, if we are having ND array, this is probably 2D array, if I am not wrong. ARR2D, yep. Yeah, if you see it's a 2D array, if I check the dimensionality of this array, 2D.ndim and ARR2D.dtype and ARR2D.shape. So these are some useful methods related to this in order to see. So yeah, the dimensionality of this array is 2, the data type is this, and the shape is this 3x3. So this time if I'll try to access something like this will just return me the first dimensionality or something like this. Like, this is like on first index I'm having another list, so it's basically returning me a whole kind of list, and that's what they're referring to in this part. They're like, if you'll pass 2, it will go inside this array, this one, and it will like, oh, on first index I'm having this, and on 0 I'm having this, on 1 it's this, and on second it's this. So it will simply give me something like this if I'll pass something like this. But if I want a specific thing from the last list, then I again need to pass or specify another, square bracket, and inside that I need to pass the index of that stuff. So in this particular thing, it's like go on index 0, it will go here, and then I'm saying again go on index 2, so it will